Hello everyone and welcome to the final session of Warwick Data Science Society's course, Beginner's Python. Now the goal of today's session is to wrap up all of the topics we've been looking at for the past 7 weeks, kind of working towards filling in those gaps so we can actually go and solve some real problems using Python. So we're going to start off with a quick summary of what we're going to look at today. There's a fair bit of content, but we'll break it down bit by bit. Because this is the last session coming to the end of term, we're not going to be running a hybrid live session just because I know people are busy. But if you do have any questions, you can get in contact with your mentor to kind of get some support with this session. So what we're going to be looking at today is a lot of stuff regarding text files, how we can read from a text file and how we can write to a text file. So this is really important because it's the first step in us being able to read in data, say from the web or from any file that we've downloaded, and then a more convenient way of outputting our data. Rather than having to just print everything out to the user, we can maybe write log files or write some direct output like a data set to a text file. We're going to look at how we can raise errors. We've seen, hopefully many times already as we're learning, that we've stumbled across errors that Python has given us. Perhaps we had the wrong type of variable, we put in the wrong value. We're going to learn how to make our own errors so that we can make our code more informative when it doesn't work correctly to the user. Let them know what went wrong so they can correct that. And then finally, we're going to have discussion about these things called built-in packages and modules. And these let us expand the functionality of base Python to do even more incredible things. So we'll touch on that and give you enough skills to go and research yourself kind of more packages and modules so you can learn how to do various things such as more complicated mathematics, using random numbers, and really anything you can imagine. So with that, we'll pause for a second and then we'll get started with today's session. Okay, let's get started with today's content, starting with how we can read information from a text file. So we've seen so far two fairly limited ways of reading in information or data into our code. The first was using the input function, and that was used to get information directly from the user of our code. So it would create a little prompt box, they could put in the input they wanted, we could save that to a variable, then use that later in our code. And so this is naturally a very limited form of input, just because we're relying on the user typing everything out for us. A more advanced technique we saw at the end of last session was using an API. And so we saw last time an example of using the Google Books API to get various bits of information about books. And so this is a very powerful method, but it requires whatever data source we're using to have an API attached to it, and that's not always the case. Often we'll just have a text file with the data in that directly. And so what we're going to learn today is how we can use Python to read the contents of a text file and then use that in our code. And hopefully by the end of that, we're going to have a very powerful technique that we can use for a lot of different applications. So we've been coding in Google Colab, so it's going to be important to know how we can read text files using Colab. And there's an extra step we have to add that we wouldn't have if we were doing it locally on our computer. And that is uploading a file to Google Colab so Python is aware of it, and then we can use the standard code to import it. And so to do that, we have Colab open like this. On the sidebar here, at the bottom, we'll find this little file icon, and that represents all of the files we have loaded inside of Colab. So by default, we start with the sample data. There's a few data sets we can use, and I've uploaded this extra one here. And so if we want to upload a new file, we can click this little up arrow with a file button, and it's going to let us upload a file from our local machine. So here I have 3 files we're going to be using today, which you can find on the GitHub. You can just download those. And so if we want to import one of those, let's say the joke, then we can click on that and open that. That will be uploaded. And if it's the first time you're uploading a file, it'll give you a little warning saying that as soon as you close Colab, you will lose that file. It's going to be deleted. So if I was to close Colab now, then reopen it, these files would have gone, and I'd have to upload them again. So just be aware of that. You will have to upload them again if you restart Colab. So that's how we can upload a file, and then once it's sitting on the Colab servers, kind of on the same instance that we're running Python on, we can then use Python code to actually import the contents of that file. And so we're going to be playing with a a text file that looks something like this. It's a reference to Monty Python's sketch, The Funniest Joke in the World. Monty Python being kind of the reason that Python is called Python. And it goes something like this, just 5 lines in nonsense German. And you can find these by following the link in the presentation or on the GitHub. Let's just have a quick look at how we would do that. So if I open this link here, this will take us to the GitHub. And if we want to download this joke.txt, we can click on it. That's going to show it here. We want the raw format of this. This is kind of a formatted version on GitHub. So we click raw. It's going to open the raw text file. Then we can either right-click Save As, or use Control-S Windows or Command-S on a Mac. And then that will let us save it somewhere on our local machine. We can then upload that onto Colab. So that's how we can get access to those files there. And then once we have that, we can actually load this text file into Python. And we do that using this syntax here. So it's a bit of a verbose syntax. Let's break it down bit by bit. So the important thing is open this text file. So open, and then in quotes, the name of the text file. So this is called the_joke.txt. So we're going to open that, but this is just a connection to the file. It's not the file itself or the contents. This is opening a connection to that file. And so what we're going to do, we're going to, with this connection, we're going to do some code. So with this, and we're going to give this connection a name, just so it's a bit easier to reference. And so we're going to use this as keyword to kind of alias or assign a name to this connection. And we're just going to call it file. Some other names might be F is a common one. You might call it the joke. You can really call it anything here, but we're going to use that to reference that connection. So with this connection as whatever name we're going to refer to it as, we then have a colon, and then we have an indented block, and in that indented block we have access to this connection. So what we can then do is take this file and then use the .read method to read in the contents of that file. And then we can assign that to a variable contents. Now, what this whole notation is called is a context manager. And so what this does, it creates a context in which a connection to that file exists. So wherever we're indented here, this connection, which we call file, which connects us to this text file, exists, and we can read from it and do whatever we want with it. And the reason we use a context manager is to handle some kind of technical aspects of reading a file to make it just easier to work with. Because an important thing when we're dealing with text files is that if we open it, we want to close it again at the end so that other programs can read the text file. You can actually read text files with another syntax in Python, more old-fashioned syntax. You might see this some places on the web, but that old syntax requires you to actually close a file connection after you've opened it. And if you don't, you can run into problems where two programs are editing the same file and overwrite each other. But by using a context manager, we never have to bother about closing the file. As long as we're in this indented bit, we have that connection. And then once we stop indenting, the connection automatically closes and we don't have to worry about it at all. And because we've assigned the output of reading this connection into the context variable, we can still access that outside once we've closed that connection. And so that might seem a bit complicated, but the important thing is this pattern here. So with open whatever the file name is as some kind of name for that connection, and then take that and use .read. That's going to read the contents out into whatever variable we want here. And then we can use that variable that's just going to contain the text as a string. And so so I think a while ago we talked about how there were some white lies about how the print command worked. But actually, we could output things to Colab without using the print command, as long as we only had one thing we wanted to output. So if we just put a variable's name, that will actually print it, but if we put two variables' name, it will only print the last one. Or we can use print on both of those to print both of them out. So there's actually even more white lies on top of that original white lie, and that is that using print and just putting a variable by itself have slightly different outputs. And we actually discussed this in the additional notes of session 1. And the technical difference is between these two representations of strings called repr and an str for string. Now, we're not going to get into the details of that. The important thing to bear in mind is that just typing a variable name and typing print that variable might give you slightly different outputs. Like generally, they'll be basically the same, but might be slightly different. And so why this matters in this case is that using print on some text data will evaluate all of the special characters. Because in a text file, there's lots of hidden special characters that we don't see, such as tabs, such as spaces, new lines. Those kind of don't visibly display as characters. They just control how our text is formatted. But those are stored in the string itself. And for example, the string for, the character for a new line is /n. And so if we just take this content, which we had from reading this file, whenever we had a new line in the original text file, we have a /n here. So this is just one long string with /n's in. Only when we go to actually print it do those special characters get evaluated and we end up with the multi-line text we wanted before. So just bear in mind that there's slight differences between here, but essentially they're the same thing, just how they're displayed. So we saw there how to read in a text file as one long string with all the special characters in, but we might want to instead read a text file into a list with one element of that list per line of our original text file. And so there's a few ways we can go about doing that, but I'm going to use what is arguably the easiest methods. And that is to read in the file as a single string and then split it wherever we see a new line character. So we start the same as before, so with open and then the name of the text file we're opening, as long as we've uploaded that to Colab already. And this time I've given this the alias, kind of the temporary name of f. It's kind of the shortest name we typically use. We then read the contents of that connection into a variable called contents. So we're just doing the same as before now. And then what we do, rather than printing out contents straight away, we take contents and we use the dot split method to split wherever we see a /n. That's a new line character. And we do that. That's going to give us a list of every single line in that original text. We split wherever we saw a /n. And if we print out lines or just use lines by itself, if we only want to print out one thing, we don't need to use print, although the output might be slightly different. Then we'll see that we now have a list, so square brackets, where each element separated by commas is the strings representing each line of the original text. So that's how we can approach something like that. So with that, let's have a go at working on a puzzle around reading text. So instructions are here. We'll come back in a moment to look at the answer to that. Okay, let's take a look at the solution to this puzzle. So a lot of the code is very similar to what we had before, but with the added addition of a loop at the end. So we open a connection to the file password.txt, assuming that we've loaded it up into Colab already. And we open that with the alias of f, so we can refer to that connection as f. We then read in the contents of that file using the .read method on this connection, and then save that into contents. We then split out all of the lines by using .split on the new line character, so split every time we see a new line. This gives us a list of lines here, and we can loop through a enumerated version of this, looping through the line number and the contents of the line, where this starts from 0. And then we want to print out every 10th line. And so we can do that by asking, when is this line number divisible by 10? So when is the remainder when we divide by 10? That's this percentage symbol here. What's the remainder when I is divided by 10? When is that equal to 0? And in that case, we print out the line. And turns out the results for this are the lyrics of Rick Astley's Never Gonna Give You Up. So let's have a look at how we can read large text files. Because the method before is okay, but it relies on reading the whole text file in one go. That's fine for smaller text files, but if we have a very large file, say many gigabytes, we're not going to have enough memory on our computer to load that in one go. And so instead we might want to load the file in one line at a time, process each line as we go, and then work through the whole thing sequentially. And so we can do that by using the read line method rather than read. So read reads the whole thing, read line reads one line at a time. But apart from that, things are fairly similar. So we open a connection to the file as we would before. We can open this with an alias for that connection of f. But then rather than using read, the read method, we use read line. That's going to read in one line at a time, working through the file. So the first time we run that, it's going to read the first line, and the second time we run that will be the second, third, fourth, etc. Now the problem with this is that this will read out the line in its entirety, including that /n, that new line character at the end. And that's not very informative text. If we're reading the line, we probably don't want the new line at the end. And so we probably want to replace that by following this with .replace, and then we replace all /n's with an empty string. So this is just two quotes with nothing between it. That's going to get rid of those new line characters at the end. Now we're going to do, this is kind of a bit of fancy Python here. I'm not going to get into why it works. If you look at the additional notes, I forget which session it is, but the topic is about truthiness. You can learn why this works here. Basically what this is going to do, this while line, is going to keep running while there's still a new line in the file. And basically once we reach the end of the file, this line's going to kind of almost be the same as false, and we're going to stop doing this while loop. So while there still is a line, print out what the line is, and then overwrite the line by reading the next one. So we start here just to fill the line. We could have also set this line equal to true initially. That would have started things off, then put the print after. But another way is just to read the first line in and then keep overwriting that by reading a new one in. So a bit repetitive. Hopefully you can figure out what's going on here. So we print out each line, and eventually we're going to run out of lines, in which case f.readLine is going to return a special value, which is going to tell the while loop to stop running, and then we exit that and we'll automatically close the connection to the file. So in all, we print out each line to get the same thing as we did when we read the whole thing in one go. But with this method, we only ever have one line in memory at a time, so it's a lot more efficient. So let's have a go at applying that to this puzzle, then we'll join back again in a moment. Okay, so let's have a look at the solutions to the two parts of this puzzle. So the first one was repeating the exercise we had before, but by reading the file sequentially. And so we can do that by kind of augmenting the code we had looked at just previously. So we read in each line as we did before, and we overwrite the line with each new line inside the while loop. And now all we have to add is a counter to keep track of where we are through that file. So for loop doesn't work now. A for loop relies on the fact that we know how long the loop's going to be. But if we're reading a file sequentially, we don't know how long it is until we get to the end. So we use a while loop and a counter instead. So we set the count to be 0, and then we increase that by 1 each time. And then if the count is equal to multiple of 10, so when we divide by 10, we get 0, we print out what the line is. That gives the exact same output as we had before. And so then the second puzzle was to read the first 3 lines of a file. And so we can do that by opening a connection and then looping in a range of 3. So we're going to loop through 3 times. And then we're going to just read out what each line is and then print out the line. So this is going to give us some issues if the file doesn't have more than 3 lines in it, in which case we'll get kind of printed a strange value instead of an actual line, but it will still run. So just be aware when you are doing things sequentially, you can run into issues if the file isn't as long as you expected. Whereas when reading the whole thing, well, you have the whole thing, there's no worries there. Okay, so now I'm going to have a look at how we can write to a text file, so the opposite of what we've just been looking at. And unsurprisingly, whereas we use .read to read the contents of a text file, we can write to a text file by using .write. And the rest of the syntax is fairly similar. The important thing to note is that we have to automatically we have to manually put in our /n's to add new lines to our file. So if we don't put these, we'll just write things out to one long line in a text file. And so when we open a text file and we want to write to it, we have to specify the mode we're opening the text file in. So by default, we open it in read mode, which is referred to by the letter R. But if we're not reading a file, we have to manually specify whether we're in write or append mode. So what write mode is going to do is just completely overwrite a file. So even if that file already exists and already has content, if we open a file in write mode, we're going to just completely overwrite that with new text. If instead we open it with append mode, then we're going to add to the end of the file, not deleting anything that exists there already. And the symbol we use for both of these is a W for write and an A for append. So the syntax is very similar to before. So we open a connection to the file, but we add an extra argument here, separated by a comma, which is a W, the string W, to represent we're opening it in write mode. And then we just give this an alias as we did before. And so now we can do whatever we want, but rather than using .read to read the contents, we use .write to write the contents. So we can run .write multiple times. But the important thing is we have to put our own /ns in to add new lines. So here we loop through from 10 to 0, so 10 to 1, because we don't include the final thing. Each time we convert I to a string, so we can concatenate, and stick a new line at the end. So what this is going to do is going to create a text file with 10 on the first line, then 9, 8, all the way down to 1, each on their own line. And if that file already existed, it's going to be completely wiped, and we're just going to end up with this 10 down to 1. Now, on the other hand, if we open a file with append mode, so a comma, then a string A, then this is going to append to the end of the file and won't delete anything if it exists there already. And so here we can maybe finish a count up that started with 1 to 5. We can add on 6 to 10. And each time we do the same thing, convert this index variable to a string, and then add on a new line just to make sure we have those new line characters at the end. So with that, let's have a go at actually applying this to some puzzles, and we'll join again in a second to see how we would have done that. Okay, let's have a look at how we would have done that. So we're doing two writes here, one in write mode and one in append mode. So we start by asking the user for their name. We can use the input command for that. And then we open this file, user details, in write mode. And so then whenever we write to the file is going to delete anything in there already and just replace it with this new content. So we write out name, and then we add on whatever the input name was. So we end up with name, colon, and then whatever they inputted. We can then ask the user for their favorite food, and then open the file again in append mode. And so now we're going to add on to the end of the file rather than deleting the contents. So we start off with a /n so that these appear on different lines. We then type in some text and then fill in whatever they answered to this question here. So we could have done this in one step, both of them inside of here. We could have done f.write and then another f.write, but this is just an example of how we can differentiate between writing and appending to a file. Okay, so we're now going to have a look at raising errors. So far, the only way we've had to tell a user that there's an error is to give them some sort of message and then use control flow, so if and else's, to change the way our code runs. And so this is an okay method, but it's not the most formal and it's not the most robust. Instead, what we'd like to do is, if an issue arises, stop everything. Rather than having to kind of figure out how our code should flow, if there's a serious issue, everything should stop. And this is the sort of behavior that Python has. Just reconnect to this. If I put something like 4 plus hello, it doesn't do any sort of kind of code control flow. It just says there's something seriously wrong here and gives us an error. And whatever I have after that, it doesn't matter. We had an error here. Everything stops. And so it would be nice to know how we could make our own errors. So we can raise those to users with an instructive message of what they have to fix. And so we can do this just by raising an error. And so Python has many different types of errors. These are all built in. You can also make your own. But we're going to focus on the ones that exist already and some of the most common ones. So some common types are a type error. This is when an object or a variable we're using has an incorrect type. So here we had a type error because we tried to add together a number and a string. So there's a type error for that. A value error occurs when an object has an invalid value. Perhaps we're using a negative number where it should be positive. And an OS error refers to something that's gone wrong with our file system. Maybe we tried to open a file that doesn't exist. We'd get an OS error for something like that. But there really are a massive selection of types. If you Google for Python types of errors, you'll find a full list of those. So, to raise an error, we use the raise keyword. We follow it by the type of error we want to raise, and then some brackets containing the message that should be raised with the error. So in this case, the message was unsupported operand types for plus, int, and string. And so, for example, we could create a function here. It's called count2. And if everything works correctly, we're going to just count from from 1 all the way up to that number. Now, for that to work, we have to assume that the inputted number is positive or bigger than 1 at least. And so what we're going to do, we're going to say if n is less than 1, then raise a value error with the message n must be positive. And so we just put that in brackets with some text here to say what the error was. And then when we run this function, if we have a valid input, it works fine. We have 1, 2, 3, 4. If we have an invalid one, it's going to raise an error. It's going to be a value error. It says where the error occurred and the message that we specified. So we have very professional errors the same way that Python would give them to us. And we could add more errors here if we wanted to, maybe checking that the type should be an integer and other things like that. And so in order to do this, it's going to be helpful to have some functions for validating input to see whether they satisfy certain properties. So first, how do we check the type of an object? So various different ways here, all kind of with the same sort of syntax. Let's say we have an object here which is x is equal to 4. And we can use this function here isInstance, which takes an object and a type. So this is going to say, is x of type int? Is it an integer? We can do the same for float and the same for string. In this case, x is 4, it's an integer, so only x is an integer should print out. Float and string would print out if this was a float or a string, respectively. And we could put any type in there. We could put tuple, we could put list, all the different things. We can use that to verify if the type is correct and raise a type error if not. Here we check for whether a string is of a certain format, whether it's numeric, whether it contains only letters. And we can do that using isNumeric, that's saying is everything only numbers, and isAlpha is checking if everything is only text. So you could use this, for example, to check whether a certain input from the input function was actually a number. And that helps us deal with the issue we saw many sessions ago where someone could type in the string, the literal word 24, rather than the number 24. We could use this to validate that. And so here y is the letter A, that's not numeric, but Z is, because it's just the number 1. And y is alpha. Alpha means is it only alphabetical, so only the letters, no numbers. And y is alphabetic, but Z is not. And finally, we can use the in keyword to ask if a certain substring is in a larger string. So whether we can find the literal string BC somewhere inside of U, which is ABC. So here, there is BC there. It's the whole string, not kind of is there a B and is there a C, is the whole thing BC in there. So we found that, but we didn't find BC inside of V. So we don't get that printed here. So there's a few methods we can use. If you look at the additional notes for previous sessions, I think for this session too, we go into a few more details of some more advanced use cases of these sorts of methods. Okay, so let's have a look at raising our own errors through these puzzles. We'll join back again in a moment. Okay, let's have a look at how we would have done that. So here we created a function to print out a sentence. So a sentence has to be a string and it has to contain a space. We're after proper sentences here. And so we create a function using def, and it has one input, which is text. And even though we've called this text, someone might input a number, might input a list, which will validate that this is in fact some text. And so we use this pattern here. If it's not the case that text is an instance of string, so if text is a string. If that's not the case, then we raise a type error saying that text must be a string. And this design pattern here is very common, of if, not, and then something. Actually, we saw an example earlier of something like this. If n is less than 1, do this. This is actually quite bad practice. A better thing would have been if it's not the case that n is bigger than or equal to 1. And so those mean the same thing, but by having the not at the start, we rephrase them so that the thing that we've written there is what we want to be true. If that's not true, then we raise the error. And so by using ifs with a not, and then kind of reframing our condition to make it negative, then we can instantly look through this and check what conditions have to be met. So because these have nots, I can go, well, the input must be a string, and there must be a space in that. Whereas if we had it without the nots, then it would be a bit more confusing. So try and have a not at the start, even if that means reversing what your condition is. And so if this is not a string, then we raise a type error saying that the text must be a string. And if it's not the case that we find a space in the text, then we have a value error that the text must contain a space. So this is a type error because it's to do with typing, but this is a value error because it's kind of what the actual value of that string is. And if those things are satisfied, then we print out the text. And we don't have to worry about using any else's here, because we raise an error that stops everything. And so we don't have to worry about having an else at the end. And then here we have a forgiving double. This is going to let us do doubling with a number that could be formatted or stored as a string. So the inputted value is a string, then we first check that this value is numeric. And if it is numeric, then we can convert it to an integer. And if it's not numeric, well, then there's an error there, and that means that we can raise a value error saying this should have contained only numbers. And actually, we should have written this the other way around, really. If it's not the case that the value is numeric, then raise this error. So this isn't the best way of writing it, but it works okay. And now value is either going to be the original value or a string that is converted now to an integer, and we can double that and return that. So that's how we would have solved something like that. Okay, so the final thing we're going to look at is built-in modules. And so far, all the functionality of Python we've used has come preloaded by default. But we can get access to a lot more powerful tools by importing these things called modules, and specifically built-in modules. Because Python can either have modules that come installed with Python, or you're actually free to install modules from other places from the web. There's really a really vast collection of modules that we can use. I'll talk more about that at the end. And so what is a module? Well, it's basically a collection of code, so of functions and of objects. And they're typically grouped together for a certain purpose or a certain aim. So Python has built-in modules called random, which is for random number generation, time for timing things, and OS for dealing with the operating system. So stuff like creating folders, checking if a file exists. You can do that with OS. And so we can't use these by default without importing them first. So telling Python, hey, I want to use these. And the reason that we have to import them rather than having them all loaded by default is because sometimes different modules have functions with the same names and they would conflict. Instead, we explicitly say, hey, I want to use this one, so it's clear which functions we're using from which modules. So a few different ways we can import the contents of a module. The first is to import the module as a whole. So we can import the time module and then access its functions by using dot notation. So we have the time module, and a bit confusingly, inside of that there is a time function. So the time module contains a time function. And we access the time function by using the time module dot the function name. So this is saying use the time function from the time module. And what this does is it prints the number of seconds since the 1st of January 1970, which is referred to as the Unix epoch time. I'm not going to get into why this is an important date, but it's just kind of standard practice to use that. So we can print that out. You may be thinking, actually, well, that seems very irrelevant, but actually, if all you care about is the difference of two times, it doesn't matter where you count them from. So if you take the time now and in 5 seconds, no matter where you measure those from, the difference is still 5 seconds. So you can print out a rounded version of that, and that is, well, it's a lot of seconds have passed. So another thing we can do is import a specific function from a module. And to do that, we use from module name, in this case the random module, import a certain function. So here, import the randint function. And we can print out, we can use randint with the inputs 1 and 10. That gives us a random integer between 1 and 10. In this case, it was the number 8. And so there are many built-in modules, and they have a wide variety of features that you can use. And the important thing is we're not expected to remember how these work. There are certain modules you use a lot that you might accidentally remember them, but really the goal isn't to memorize these, it's to be able to search for them when you need them. And so rather than trying to memorize them, the best thing to do is to practice searching for their documentation to learn how they work. So for example, if we have the problem, I want to check if a file exists, I would go on Google and search Python check if a file exists. And the first result I get is this tutorial here saying that I can use os.path.exists. So that's the OS module. There's a submodule called path, and then the function exists. So I can use that. We see the documentation here, so it returns true if the path specified exists. And if we looked a bit lower, it would say path should be a string. So I can import the OS module, then use os.path.exists with a file. Then I could do my importing code, whatever that was, somewhere else in my code. Otherwise, we can raise an OS error saying, hey, that file doesn't exist, sort that out. So the key thing is, whenever we want to do something, we just search it. And you'll get better at searching things and reading documentation as you become more familiar with Python. So another thing I'm going to mention is aliases. We saw aliases earlier when we opened a connection under a certain name, so as file or as f. We can do the same when we're loading functionality of modules. So we do this typically if a module has a very long name, we want a shorter name for it, or to avoid importing two things that have the same name, we can rename one of them. And so we do this using the as keyword. So we could import the datetime module, but that's quite a lengthy name. If we're using that a lot, we might want a shorter name. So we can import that as dt. And so now dt refers to the datetime module. We can do dt.thedate submodule .today is going to get today's date. Or we can import a certain function as a shorter name. So from the random module, we could import normal variate, which gives us a random, normally distributed random variable. And if I'm an R user, for example, I would be more familiar with calling that rnorm. And so I might want to import that as rnorm. I can use rnorm with 0 and 1 to get a normal random variable with mean 0 and variance of 1. So we just use this as keyword to rename things. Okay, so with that, let's have a look at how we can use those built-in modules to do these exercises here. Okay, let's have a look at how we would have solved those. So some quite lengthy bits of code here. There's some quite complex work here, but we get some quite nice output from it. The first one is a game of higher or lower. So we import the random module as rand. Normally you would just import random, but to prove the point that we can use aliasing, we've imported it as rand. And then we create a random number between 1 and 20 using rand.randint. We're going to keep track of how many tries the user has, initially 0, and they're initially not correct. So correct is false at first. And this correct is going to be important for kind of keeping track of why we've exited the loop, because we can either exit because we run out of tries or because we got a correct answer. So we need this correct just to keep track of that. And we assume that they're incorrect by default. That's just going to make our code look a bit easier. So we're going to keep looping while the number of tries is less than 3. Every time they have a guess, we'll increment this by 1. After 3 tries, they give up. So we take their guess by taking an input and converting it to an integer. We assume they give a sensible answer. We could have validated this if we wanted to. If the guess was equal to the answer, then we're correct. We set correct equal to true, and we break to exit that loop. Otherwise, we say if they're too low or too high, and increment the tries by 1. So when we exit the loop, either tries is bigger than or equal to 3, or we broke here. And so we'll know which one was which by looking at correct. If we broke here, then correct must have been set equal to true. That's the line before. Otherwise, we never got into this bit, and so correct must be false still. So we can look at correct to see whether they won or not. So that's some nice code there for a guessing game. And the other one, consider looking at the combinations function from itertools. And we can use this to loop through all the various pairs in a list. So we print and Bob and Cat and Bob and Cat. And this would work no matter how big the list is or how many we wanted pairs or triplets or anything bigger like that. And so, wow, yeah, that brings us to the end of this course. So thank you for making it through this whole thing. Obviously, it's been a long time going. We've learned quite a lot. And it may be hard at bits, but hopefully you feel like you've learned a lot of material now and can maybe start going to apply it. If you're kind of following this with the society, make sure to check out the WDSS community group on Facebook. That's where we post a lot of our research opportunities, and often when we finish one of these courses, we publish a few research, beginners research posts that you can get involved with to kind of apply these techniques to some actual problems. You can be guided by our research team in doing that. In terms of kind of next steps, WDSS are currently working on or have made, depending on when you're watching this, a more advanced Python course which you can check out. Just have a look on our Facebook if you want to kind of see if we're doing anything related to that, or check our YouTube out. If you look at our playlists, all our teaching playlists are on there. You can find that. So in terms of next steps, if you want to kind of push yourself further, there are a lot of resources for Python on the web. If you want to kind of learn Python for data science, DataCamp is a great way of doing it. It can be fairly expensive, but it is a really good resource for learning how to code. Otherwise, there's many free resources. If you have a look on the blogging site Medium, or sites like Geeks for Geeks or Real Python, there's lots of tutorials on how to do certain Python projects. Or another good book is Automate the Boring Stuff with Python. So those are some things you can check out to try and apply these further. The important thing is just stay inquisitive. Don't be afraid to Google or to ask for help. It does take a long time to learn Python, but hopefully now that you've got the basic ideas and have worked through maybe the hardest bit, which is starting, it should be a lot easier to kind of carry on and learn more for yourself. So thank you for making it through this course. If you're doing the hybrid live sessions, the information will be in the Teams on how to get certification. But otherwise, thank you for watching and see you soon.